I'm in the process of rewinding this vintage electric motor. It's from a MADAS mechanical calculator. It's over 100 years old, and in the previous videos I've gone through disassembling this rotor, and the issue with this was that it had a lot of leakage to the shaft, so I couldn't use it, and I decided to rewind it. The motor's very rare, so the chances of finding a replacement were pretty much zero. So after a lot of effort I unwound the motor, ended up with a winding table, and it turned out that although the motor had been wound in a bit of an odd sequence, the actual connections were fairly standard for a series wound motor. So I could have taken the easy route and just rewound it as a sequential set of windings around the rotor. But to keep it authentic, I've decided to rewind it exactly as it was originally wound. Won't make a huge amount of difference, but it will give it that authentic touch that it had, and that's obviously what I'm trying to achieve here. So as you can see, I've already started. In the previous video I cleaned up the rotor. I've now fully insulated this, and as you can see, I put on the first pair of windings. And so the way this is wound, I've marked what amounts to segment 1, or what I'm deeming to be segment 1 on the commutator, and the slots are numbered, or rather I've given these slots letters. And the way that I'm using this winding table is obviously in reverse. So this is what I removed in order, and so what I have to do is put the windings back on, starting with the last winding I took off and winding it back on in reverse of what I actually took off. So for example, when I took the windings off, I was unwinding anti-clockwise with the winding on the top side of the shaft, and so I'm winding it back on clockwise and making sure that, for example, these first two windings started at commutator segment 21. That first winding of 100 turns was terminated on segment 20, and the next winding, which goes in the same slot, went from 20 and was terminated on 19. I've soldered the center one on because there are no more connections to go there, but I can't solder the two ends on. I can't solder 19 and 21 yet because there's another wire that goes to each of those. So I don't want to fill the slot with solder and make it difficult to get the next connection on there. We'll get more cumbersome as we get more windings on, but it's better doing it this way and making sure we end up with a properly viable result. So what I'll do now is get the next pair of windings on. So the slot I wound into is what I've defined as slot M, and so looking at the diagram, it's this slot, and the next one is slot L, and in theory it should be the effectively matching winding on the other side of the rotor. So N goes from here round to here, and L goes from the next slot round to the next slot. So that does seem to make sense, and all I have to do is make sure that when I wind L, I connect it correctly between these three commutator segments, which is 7, 8 and 9, but in reverse. So I'll be winding it from 9 through 8 to 7, and then there'll be two windings again, each of 100 turns, going into slot L. So I'll get that done, we'll have a quick look at it, and from that point on I'll probably just complete it, and then we'll look at the finished result. So that's the first 4 windings put back on, and I'll just continue in this fashion until all 24 have been rewound. It's not particularly difficult, it's just tedious, and it makes it more difficult having this weird order that they're being wound on, because I can't just easily connect and solder on each of the ends, and it just makes it a bit fiddly to terminate them. But the windings are all fairly straightforward to put on, they're just time consuming. So I've done the first 4, I've got another 20 to do, and then once I've done that I'll again give it a full pat test, and assuming that I don't have any leakage, we'll reassemble the motor and see if it actually works. Okay, so I'm about 2 hours in and I've got 8 of the 24 coils wound. You can see what I mean about them not progressing from pole to pole around the rotor. They kind of jump around and it does make it quite difficult to wind. But they are wired to the commutator in the standard form, so it is fairly easy to keep track of. And I'm just replacing the windings exactly as they came off, and what I'll do once I've finished winding this is put it in the motor, run it up, make sure it's all working fine, and if that's okay, I'll take it back out, impregnate this with epoxy, and then once it's cured, hopefully assemble it for the last time. But I've got another sort of 6-7 hours of rewinding to do, and then I'll give you a quick look before I test it in the motor. Okay, actually a few days later, and I've now got 16 out of the 24 coils wound back on, so another couple of hours work and I should have the motor rewound, and then I can do an initial test. So I'll get this done as soon as I can and see if we can get this motor up and running. Okay, so that's the rotor rewound. A total of 2,400 turns, about 400 meters of wire, and I did rewind it in exactly the same way as the original. It's not the way you'd wind a motor if you're doing one in a more modern style, but the actual interconnections are the same. So what I've been doing as I've been testing the final winding is to make sure that all the windings are of course intact and properly connected. So you'll find that they vary slightly because obviously the length of some of the windings are longer than others, depending if they're on the top or on the bottom layers. And this is one of the reasons that it's wound in this fashion, because it keeps the winding resistance fairly consistent. And what I do here of course is just check between each adjacent set of commutator contacts, and we should get a fairly similar reading. If we get a much higher reading, it's because that particular winding would be open and the conductive path is going right through the entire string of windings. Now of course the reason that they're wound like this rather than being a lot of people seem to think that the brushes just operate on one pair of coils at a time, and it doesn't. It actually energizes all the coils at the same time apart from 2. So 2 of them are all shorted out by the brushes, because obviously the brushes will be spanning one of these pairs of, or rather 2 pairs of the commutator contacts, and that particular coil will of course be shorted out, which is why the timing of the commutator relative to the windings is important. But it means that effectively you have 11 coils in each of the 2 strings between the brushes, all in series, wound around the core. So effectively you're energizing all of the poles at the same time. And although you have one pair of coils shorted out, because there are 2 coils in each pole in effect, then the entire rotor always has a magnetic field all the way around it. It's reversed of course on one side relative to the other. And that makes the motor more efficient and more powerful. And that's why they're wound like this. It just means that you have to take into account the fact that although we have 100 turn windings, then we're not putting mains across the 100 turns, we're putting mains across at any one time 11 of these in series. So it gives us effectively 1100 turns on each side, and that's why the motor's not going to burn out with just 100 turns. Also of course what I've been doing is making sure that there is now no earth leakage between the commutator and the rotor shaft, and if you recall, in one direction I was getting about 7k and the other direction I was getting between 50 and 100 meg, and now I'm getting nothing at all in either direction. I've tried a full test on this as I did before. I won't show it again. I've done this a few times. I'm sure you're getting bored with this motor now. But there's no leakage on this whatsoever, so it's cured that problem, and as long as it will run and I haven't made any mistakes in winding it, then the motor should be good for another 100 years. So what I'll do in the next video is try reassembling the motor. We'll run it up at slow speed, assuming it works. I'll then impregnate the rotor with epoxy to keep all the windings in place, and then give the motor a full test. I don't want to run it up to high speed until I've got the epoxy on here, because otherwise the windings can start to fly off the rotor. Okay, so it took about 11 hours in total to rewind. It's a bit of a tedious process because of the weird way that this motor is wound, but it certainly seems okay and all the windings test okay, so I'm hoping that the motor will actually run.